Shamim Akhtar's. Today we're going to talk about of Java threads and multi-thread programming. So the topics is very important topics for you guys because computer science and engineering, like you have to developers or wherever you are going, so you need like to handle threads and controlling threads. Okay, so that's very important part for your career as well. So that's why this topics is very important. Although we are learning with Java, so you can implement with any other languages as well. But we are going to learn the syntax with Java, but you can implement with the different languages, no problem. But you have to learn these things. So we are mainly focusing on the creation and manipulation of Java threads. So these lectures, we're gonna focus on the Java threads, like how to create Java threads and how to control the Java threads. That's basically we are highlighting these topics to this class. The objective of this class to get, a program can have many tasks and they are able to run concurrently. They are able to run concurrently. There are many program can run concurrently. There are many tasks in the program and they can run concurrently. So a thread is a flow of execution from the beginning to the end of the task. So that means that we may have partitions. If your program is this one, we may have several partitions in the program. Each partition is called task. Each partition is called task. And each task can runnable concurrently. Those are runnable concurrently. Those are runnable objects that can run concurrently. Okay. So each task are runnable objects that can run concurrently. So thread is a flow of execution of the task from the beginning to the end. Flow of execution of the task from the beginning to the end. So that's mean the execution is basically the thread. Task execution is the thread. And tasks is runnable objects which can run concurrently. So there are many tasks in a program. There can be many tasks in the program. They are independent and they can runnable independently. That's the main focus. Okay. So a thread is the execution flow of execution from the beginning to the end of the task. So a task, so if this one is a task, so from the starting point to the ending point, all the instruction execution is basically a thread. Okay. So multi-threading enables multiple tasks in a program to be executed concurrently. So multiple tasks can be executed concurrently. So that's mean multiple tasks mean multiple thread. So multiple thread can have in the program to execute multiple tasks concurrently. That's basically called multi-threads. Now, when you say concurrently, what is concurrency? Concurrently, that's very important to learn. What is concurrently? Concurrently and parallelisms, there are two different words. Concurrently is about dealing with a lot of things at the same time. I mean, at once you are dealing with the many things at a time, but you are not running them. You are dealing with them, but you are not running them. You are not running them at the same time. Parallelism means you are dealing with a lot of things as well as you are dealing with multiple threads, but at a time, only one thread will run. That's basically called concurrency. So, and parallelism is multiple threads you have, all the threads are running in parallel. That's basically called parallelisms. Let's see, I have a task where I have a task. The task has been partitioned into three parts. So thread 1 is the execution of this task. Thread 2 is the execution of this task. Thread 3 is the execution of this task. So execution, who will execute? CPU. So this one has a CPU, so CPU 1. So this thread 1 is running into CPU 1. Thread 2 is running into CPU 2. Thread 3 is running into CPU 3. So if I have 3 CPU, so thread 1 is running at the same time, I'm executing and dealing with multiple threads. I have multiple threads and I'm executing them parallelly. So they are parallelly runnable. So they are parallelly running because we have three CPUs, separately three CPUs running three threads. This is called parallelisms. At the same time, we have three different execution of the threads and they're executing, threads are executing. But when you have concurrency, then we have the same things we have. So this one will be in here, this one will be in here, and this one will be here. So now we have only one CPU, only one CPU. So that's why the threads will share the CPU, share the CPU, share the CPU. How? Time sharing system, time sharing systems, where we have a time slice to maintain, time slice. Okay, so let's see, this one is the time slice we have, which is 5 nanoseconds. So as we have one CPU, so only one thread can run at a time, but we want to deal with multiple threads. So multiple thread, I will run this one 5 nanoseconds, then I will move another seconds threads. In that way, I will come back again and I will execute some other parts 5 nanoseconds, and then the second one's other part, third one's other part. In that way, I will complete the processes. That's basically called concurrently. The processor threads are executing concurrently. So at an instant time, only one thread will execute. At an instance time, only one thread will execute. Other thread will not execute. But here parallelly, they are executing independently. At any moment of time, they are executing independently with different CPUs. And here we have one CPU. Now, these ones are called seemingly parallel. Nearly parallel. Why? Nearly parallel. Like seemingly parallel. You can feel parallelisms. Parallel. Like when you hear a song in the computers, like now I'm writing, I am reading, and um, I am also creating video, presenting, right? So there are three tasks I'm doing at the same time. There are many tasks going on. So what the CPU, I have only one CPU. The CPU is moving from one process to another process and in a faster way, so that we can feel that it's coming back in a so faster way, so that we can feel that, okay, it's running parallelly. But actually, it is running 5 nanoseconds, 5 nanoseconds, 5 nanoseconds, then come back. So 50 nanoseconds is just like I drop. So that's 50 nanoseconds. And within that time, the CPU will come back to us. So that's why we feel that our program is running parallelly, but actually the program is running concurrently, time sharing. So it's sharing the time between several threads and concurrently executing. Any question? Do you have any question? No, okay. Let's go to next. Create threads by executing thread class. Now we're gonna, so let's first go to task 2 first. Let's go to task 2. That's easier for you. Okay, task 2. Okay, let's go to task 1. Let's go to task 1. Okay, so create threads by executing thread class. Okay, when you're gonna use a thread, the thread must be to, okay, a class create threads by extending the thread class. So first we have two things here. One is that we have to create task first, and this task will extend thread. That means the task will be extends threads. The thread will be the parent of the task class. So when you create an object of the task class, task, you want equal to new task. Basically, we are also creating an object of the thread as well. This one encapsulates the task because the parent constructor will call. Parent constructor means that parent object will also create. So within the task, the parent objects are also there. So that's means thread has been created. So now, when you call the task we have, when you call, so here we have threads actually, threads also. So when you call T1 dot start, then the task has been started. The thread has been started. So actually the thread has been created and threads has been started. Thread will be run. Okay. Now, to run a threads, the tasks need to override a method which is called run method, which is inside the thread class. We need to override this one. Whatever I will write here, that is my task basically. So that will be executed by the thread. So when I call T1.start, so that's mean that I am going to call the run method of the thread. So of the task objects, run method I am calling. So I'm using start to call the run method. So start is in the thread. So through that start, I am connecting the run method of the task class. And that way, this one will be executed by the thread. So let's see how we can do. So we have a program which is called thread test 0.java. Let's go for this one. Please try to understand. If you don't understand, let me know, okay? But don't say that you have understand without understanding. Thread 0.java we have. So thread 0.java. So we have a class which is basically the task class. So here in this way, so thread can be created into two ways. Thread can be created into two ways by extending thread class, thread task can be created into two ways by extending thread class or by implementing runnable class. Implementing runnable class. Runnable interface, sorry, runnable interface. So there are two different ways. So we are learning first this one, and then we'll go to the second one. First learn this one, okay? Extending threads. How can we extend the thread and run? Okay, the first one. So first we have to create the task. For creating a threads with extends threads, we have to create a task class. And which will extends threads. This is the first task we need to do. So that is the first task. So let's create a task class. Task class is, you see, class print name threads. So this is my task class. Extends thread. And then inside the class, so as inside the class, normally we can have a constructor. So this one is my constructor, and I can have a run. I can have a run method. So run method is an override method. So override run method. Override run method. Run method. Now, what is the run method? At the rate of thread class. So thread class has a run method. So we are going to override this one. And this is the task that thread will do. The task class, there is no task except the run method. So you will just run method. So initialization should have done through the constructor. Otherwise, the task is the run method. So what is the task? So we'll print this line and we'll print that a character will pass. That character is the name of the thread we'll provide, and that will be run 10 times. That will print 10 times. That is the task we're gonna do. So these are first task. Okay. So now how to create a thread? So task class has been completed. Now we have to move to create the threads. So what do we need? Task class, task object we're gonna create. Create an object of the task objects in your driver class. So inside the driver class, we have static void main. Inside there, we are creating a objects of the task class. So let's create a task object int1, and we are passing name A. So A has been coming here and super A. So the super means calling the thread class constructor. So thread class constructor, we are passing the name as A. So this one is the name. Okay. So, and it will assign to thread. Okay, so when you call get name, then the thread you pass the string that will be provided in here. So this is thread has a get name method as well. So we are calling the get name. So he will execute, he will provide this name, whatever the name is. So A. So A will print. So get name here also. So A will print 10 times. That's what we're gonna show you. So what we are doing is that creating a task objects, and we're gonna call task objects, task object reference variable dot start. So we're gonna call the start method, although there is no start method in here. So how can we call the start method? Start method is inside this thread. So we call the start method. So calling the start method means that it will, compiler will redirect this start method to the run method. Actually, you are calling the run method, not start method. You are calling the run method, but as this one is a thread class we have, so that's why we are calling start. So start reflect to the run method. So that's mean it will run this one. So that's basically our threads. Okay. Any question? So that's basically our threads. So what we did, first we created task class by extending threads, and we have a constructor, and we override the run method. Run method is the task that you want to run, execute the threads inside the thread. And then we have the driver class. Inside the driver class, we created objects of the class, object of the task class, and then object difference variable dot start. That's basically our threads. That's we are calling threads. Okay, so that is our threads. So that's mean that this one will be executed by the thread. Okay, let's see how it's work. So when we compile, you'll see a run method has been called, and get name is the A because we have passed A to the thread. So get name has got A, and A has been printed. So A has been printed 10 times. So that's we are printing by a thread. Now, if we have multiple threads, what we can do? Fine, the same thing we need to do. The task we have to create another task, and we have to start that one. So we can create this one in this way. Okay, so actually, we do not need to use those lines. Okay, so those just printing just some information. So I do not need this. Just to understand. First, you have to understand this one, and then I have creating another task. This is two print name thread. Let's see B. So this objects is gonna responsible to create another threads, which is like p2.start, pn2.start. So we are creating another objects. Let's see. So this one will execute one thread that will run. This one A will print because we have passed A, and then we have B. So if we pass B, so thread has got B. So the get name will provide us B. So that B will be printed by 10 times. Will be printed by pn2 start. So when you run this one, you will see that it will execute. Now we have two threads. Now we have two threads, one threads and two threads. In that way, you can basically execute the threads. Okay. Now we can also change the workload of the threads. Okay, like some threads have much larger workload, the other threads may not have larger workload. How can we do that? You know, the loop is the workload now in here. So loop is the workload. So we can increase the loops. So we need to increase this one, this value, right? So we can take a variable in here inside our task class, which is integer, like let's say private integer. This one is a private in this class, private integer. Let's see, we have L. L is the and we are passing L in here. We are passing L in here. So let's see, we are also passing length integer length in GTH. So we are taking L equal to length. You can write this dot length, so that's better for you. This dot L, so that you can understand that this is the this class L we are taking. So now from here we are taking that length is 10, and here length is, let's see, we are talking length is 20. Now for this loop, as this one is inside this class, so he can access L, so he can take L in here. So now for the first thread, it will execute and write down the name as 10 times, whereas the second one will execute 20 times. Let's see. See this one. This one is the 10 times, and this one is the 20 times the thread is running. So in that way, basically, we can execute different threads to, although there is a single functions and the body can be executed. Run is the method which can be shared with different methods. Okay, different methods. You can also create different way, like different thread task class also different, like you can do in this way. Like here you can have task threads extends one, so you can just place a directly in here, a directly in here, a directly in here, and let's see, I'm placing this one as an A, so I want to print A. So, and this one I'm closing this one just to show you an examples of okay. So, and then this one is my print one threads, and I can create another class which can be for thread two. That also I can do. That also I can do. I can have another class which I can call print thread two. Just extends threads, and I'm calling here B. That's the difference I have. So now I can call print thread one in one thread one, and I'm calling thread two in two thread two. That's it. You may not need to pass the A or B in here because I have already assigned A and B directly in there. So you do not need to pass the name. Okay, so you do not need to pass the name. So we are just calling super and just length. Fine. And here also we do not need to pass the name, and we are passing the length and that's enough. Yeah. So that's okay. So we do not need to pass the name. So just 10 and just 20. Now, two different code we have, two different part of the code, two different tasks we have. So two different class, two different tasks. So that can be executed by two different classes as well. So in that way, basically, we can also like share the code, or two different parts also we can use. Okay, print thread one, and I have thread two as well. I have thread two. Okay, so that way basically we can create two different threads, and two different threads can run two different class or two different class objects. Okay, two different class objects. However, it can also run one thread. Inside the one thread we have a code that can be shared, or the two different code, two different class they can run. So that's we have seen so far, right? That we have seen so far. Any question? Do you have any question? Okay, so that way basically we can run two threads we have created. Now modify and run this method. So that also we have done. Now threads run by execute start at constructor. Okay, now what do we want to do? So let's go to the beginning. Okay, so I want to change this code to the beginning as it was beginning, so that I can go for my next section as well. Yeah. Okay. So now I'm going to the second one that now I'm going to the second one. So I'm opening this one, file, open Java text is 10, Java text 01 Java. So I want that here, what I want is that threads can run in the constructor. Thread should have to run in the constructor. Okay, thread should have to run in the constructor. Thread should not run in the method. Thread should run in the constructor. So pn1.start we have called pn2.start. So that start we should not call in here. We just call in the constructor, like the previous one, like this one. Let's see this one. We are calling like pnt start. So that start is without calling in here. Can we call in here? We can just place in a start, and that's enough. So this constructor will call the start. So rather than calling the starts in here with the reference variable, you can directly put the start into the constructor. So when the object will create, that time automatically the thread will be created. So the thread will run. So run functions will automatically create. That we have done in here. That we have done so far. That's we have done in here. So that's we did. Okay. So that's we did here. Now how? Let's see. So you see printf pn1, we close this one. So we do not need to pnt1.start. So that's why the reference variable we are not taking. So just write new print name threads A, new print name threads B. So when you create the object, so automatically the start is in pressing here. So automatically the thread will execute. So we do not need the reference variable to execute because the constructor will call and start will call. So start call means like thread has been executed. Thread will execute it because start is in thread. So thread will be executed and thread will execute this run. So that's why basically we can do. We can create the thread calling in the constructor as well. So this is the threads we have, two threads. First task. The first task we have learned that what is thread. So we have to create a threads. We have two class. One is the driver class and another one is the task class. So task class must need to extends thread class. Thread. Now this thread class thread. Now this thread class is in here. So task can have a task constructor, and also we'll have a void run method. We'll override the void run method. So run method is the task that's we're gonna execute by the thread. Okay, we can create the task object in here. So driver class. In the driver class, we can create the task objects in here and use the reference variable to call the threads run methods. So like task one equal new task. So we can call this one. If we need to parameter pass, we can pass some parameters in here, and then t1 dot start. Because this start method is coming from threads. Because when you create the objects of this one, automatically thread object has been created. So we can call the start methods from there. So this is one of the way. Or what we can do is that we can just create the objects. So during the object creations, we can make that a start call in here as well, start. So then automatically the thread will be executed and then this run method will execute. So start means the run method basically. Okay. So through thread method will execute. You can call in the constructor or outside the constructor in the driver class. Whatever you like most, you can do that. Okay. Now, one problem we can have here. What is the problem? The problem is that maybe tasks need a parent class A. Tasks also need a parent class A where we have display. So I want to call this display. Class A we have where I have a display method and I want to share with A. So I want A to be my parents, not thread. What I can do now, because A's display I want to call in the runnable here display. So I want to call this. So I want to create an inheritance between A and task. That time, this extends, I cannot write here extends. Can I write here? Is it possible? Is it possible? Anyone? Will it be possible?
No, sir.
No, why not? Sumaya, no. Then why not?
Sir, because
Yes, not possible. So that's why it is not acceptable. As this is not acceptable, so what we can do now? But we need A to be the parents. Fine. Then we are telling that okay, you can take A. Extending, you can extend A rather than threads. Okay, you can extend A. Extends A. Fine. You can call display in here. You can extend A. But as you are extending A, the run method should need. Thread doesn't have, thread has run method, but thread is not here. But you need a run methods. So you need to implement an interface, implements a runnable interface. Runnable interface. So runnable interface has run method. So you are overriding the runnable method. Run methods, you are implementing the run methods. Okay. So you extend A and display you call. So this one is the method from here. Okay. And runnable you implemented. So run method you can you can implement run method. Now here you create a task, but there is no thread here. Do we have thread? So thread object is not creating. So you have to create the thread objects. You have to create the thread objects by yourself now. Because you are implementing Runnable, you are not extending threads. So you have to create the thread object by yourself. So now we are creating thread th to create the thread objects. Previously, we don't because we do not need because we call the constructor. So as we extend, so already the constructor object has been created. But here we have to call the threads and we have to pass the task reference variable to there. So the thread will encapsulate with the reference variable. So task. So this thread has a task of this one. So that's why we have to place the task object in here. And then we'll call thread th dot start th.start, thread reference variable dot start. Previously, we have object dot start because the object contained threads object as well. That's why the thread objects dot thread reference variable dot start. So thread reference variable will place to the threads constructor. That's it. That's it. So this is basically runnable interface. So that's the benefit we can gain, that we can use. Sometimes we need that kind of things we need to do. Sometimes we require. So that times we can implement a runnable interface and then we can extend a class. So that's basically the second procedure we have. So we are going to the second procedure now on this one. So the first thing is what you need. The first thing is create a task with runnable interface, because the thread only execute runnable objects. Thread can execute runnable objects. So that's why first you have to create implements runnable interface. Implement runnable interface. And then the second task is to runnable interface. So now you have to create the objects. So create objects, task objects, object tasks. So create object task. And then number 3, create thread objects. Create thread objects. Create objects. Previously, we do not need this one because we extend, but now we need because it's runnable interface we use, but we didn't use the thread. So we have to create the thread objects and couple it with the task objects and then start thread. That's what we're going to do now. So let's see how we are going to implement. So we have now second task. We have the second task is compile and execute thread text1. So runnable interface by using. So and see the result. File open, and we are we have D drive. We have D drive. Inside the D drive, we are calling this one, and we have threads. We have thread 2. Now you see that we have the class, we have the task, which is so it's not 2. So what is that? It's maybe 1. Oh, sorry, 1. File open. We have task 1. You see that task with task class we have implements runnable, and as this one we may have constructor as well as we may have run class. We may have run methods because run method is the implement. Otherwise, it will show it is an interface and it has abstract method run. The task class cannot be an abstract class. Task class must be concrete class. It cannot be an abstract class. So implements runnable method. So runnable method. So that's why run must be implemented, override and implemented. Okay. So run will be implemented. Not fine. And then we have the task. So let's see this one. Okay. So we are closing this one. Let's see this one. So print. You see print. So first we create the object of this task class, and then we create the thread objects. One line just extra is required. The thread object need to create, and this ptn1 placed to the thread constructor, and then call thread1.start. Previously we call pt1.start, because we have the objects inside the pt1, the thread objects, because we are extending. So obviously the thread objects in there. But now we don't have. So that's why we have to create the thread place on the start. So this will create this run will execute. So 10 times the thread name. So now we are taking thread name. You see, we have passed this one as a name, and thread name we have placed as a name. So thread name is calling from the run. So thread name will be printed in here. Thus we can see. So 10 times A will print. A will print. Now, if you want to create another one, the same way, similar way, you can just create. The task objects with different parameters and okay, and then it starts. So in that way, you can run. Now, a similar way of the previously, constructor can also create those things. So we have constructor can also create those things. We do not need to create with the objects or the task objects. Okay. So what we can do in the task objects, we can create threads. How? So task object constructor. So we'll go to task object constructor, which is 1, 0. Let's go to 1, 1. So 1, 1, where we have, you see this one. Inside the constructor, we are using thread and this. You see this and name. We are passing the name as well. Whatever the name is coming, we are passing this one. And this means this means we place PT2, PNT2 or PNT1 to here. So now when you call the constructor, that means automatically this one has been placed. So this means this object. So this has been this object has been placed. Fine. So it's the same thing that we did. Okay, here. It's the same thing that we did here, here, and here. This one is the same things we are doing. So we don't need this one in here. We are calling it inside the constructor. And then thread.start. We can call the thread.starts in here. Now, what is the benefit is that we do not need to create the thread reference variable for different tasks. So what we can do is that we can create the threads in here. So when the object will be created, automatically this constructor will call and thread will be created, and this object will take this one and name as well and start. So we can get the names and we can print this one. So in that way, basically, two different threads call the constructor and can execute the constructor. So two different threads can execute. A, B, 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 and A. So we cannot control the execution of the threads. Now what do we want to do? So that is our second task that's we completed. Okay. So now threads run execution starts. That's I already mentioned here that how to run this one. Okay. So okay. So loop numbers is already I have shown here. So loop number already I have shown here. So modify the thread test one Java so that it execute starts and the task constructors. That's we have seen. That's we have seen now. Okay. Now we are going to thread priority. Now we are going to thread priority. Like how can we give a thread to priority? Okay. So which thread will execute more or which thread will not? Who is giving the priority to execute first? Okay. So that's basically called thread priority. But to execute the thread priority, we must need thread priority scheduler. Priority scheduler. Priority scheduler. We must need priority scheduler. So now the point is that priority scheduler, JVM can run priority scheduler or may not. This is depend on JVM, how you have constructed the JVM, how you have maintained the JVM, how you have specified the JVM. But if you use priority scheduler, so that times the thread which has much priority will be executed first. So there are three different priority we can provide. So three different priority we can provide by the constructor, by writing the constructor, by writing a constraints like min priority, norm priority, and maximum priority. The threads by default has a priority which is called norm priority, normal priority, which is the value of 5. Okay, and then we have maximum priority, which is the value is 10, and we have minimum priority, which is the value is 1. So those are the constraint value that can be provided to the thread when the thread will start. So that times we can set the priority before starting the thread. We can set the priority of the into the thread so that the highest priority thread can execute first if we have priority scheduling. Okay, so we have set a priority we can give like 1 to 10. The priority we can give like 1 to 10. Any value you can place to set up the priority of the task, priority of the thread, or you can use mean priority, norm priority, or maximum priority when you create the threads. Okay, so I have a program already. So from thread test2.java, I have a program which name is thread test2.java. So that one is basically dealing with the priority of the threads. You see that the simple way we have the now you see we have the threads. Okay, so extends thread. So how this one will create the threads? By extending threads. Okay, so now by extending threads, so first method, not the runnable threads, just the first method we are using, extending threads. Fine. Now we do not need to create the thread objects, just the thread1 equal to new thread, polymorphic reference. Parent class type difference variable can point to the child class object. So that's we are doing. Okay, so automatically thread object has been created. So thread1 dot set priority. We have placed the priority of this thread is 10. Thread1 dot start. You can write like pt1. So pt1 dot set priority, pt1 dot start. So you can also do that. But we are doing in this one this way. The thread1 dot set priority 10 and thread1 dot start. So the thread will execute with the priority 10. And for the second one, we have a priority 5 and it will also start. So two thread, we have one will print A and another one will print B. So one has priority 10 and another one has priority 5. Let's run this one and see what will happen in here. Yeah, so now you can see that we have some because our JVM is not working with thread priority. Okay, so JVM is not scheduling thread priority scheduling, is not using priority scheduling. So that's why sometimes it is using priority scheduling, sometimes it is not. So this one is the highest priority. So whenever it will come, so it should execute. So the thread priority is set up, but its scheduling is not using the thread priority. That's why is the output is not similar to the that's we expected. Okay, because the scheduling is different scheduling, then not the thread priority scheduling is using in the JVM. So you can also change in here and you can see. So just to show you that how to set up the priority, that's why this program has been created. And that's I want to show that how to create the priority in the threads. If you have priority scheduling you're going to use, so that times you can see like here you can see like the now see this one is working now according to priority scheduling. You see that 5 was before, then when 10s came, so 10 retrieved the data and 10 executed. Okay, so 10 executed, 10 complete his task, and then 5 executed. So this one is maintaining the priority scheduling. So this is depending on the JVM how he will schedule the task. Okay, so that is basically the priority scheduling that's we are expecting. But if you give here 10, so maybe the scheduling will change now. If you give here 5, so it should continue to 10 and then it will run. But yeah, so that one also okay. So 5 has been run, so then shifted to 10 and then execute. Yeah, now it is working as a priority scheduling. Okay, so sometimes it is not working because this is depending on JVM. So very careful on that. Okay, so how can you implement the priority in the thread by call thread one dot set priority. I call thread objects dot set priority, and that's enough. So in that way, basically, you can create thread priority. Okay. Now let's go to the next one. Next programs we have. So next program is telling about synchronization. It's a very important task. Is synchronizations. You have to control the execution of the threads. Okay. So how can you control? So that's by sequentializations, by serialization or sequential execution. That can be done with synchronizations. Synchronized. Synchronization, what is this? to control access of multiple threads to any shared resources. If you have a shared resource, let's see, you have a shared resource, this one as like printer. Let's see a printer we have. We have 3 users, and this one is a network printer. Okay, we have 3 users. User 1, user 2, and we have user 3. We have 3 users. One has given image to print, and one is given some writings to print, log file to print, and one is given like his photo to print. If there is no synchronization, what will happen here? You see, so there is only one printer. So he can use those things. He can use the users. He can print the user's input by concurrently. So first he will print some parts of the image. So a beautiful image, sunlight image. So, and then he is writing, hello, how are you? Today is the Friday, something like that. And then we have another image, his photo, his nose. Right. So in that way, the full documents will be printed. Is it looking good? Is it okay? Do you want that way? Is that you want? If your printer will work there like that, do you accept that? No, not. So this is called race condition. Race condition. Before completing his task, another one has task can arrive and then put the execution in there, which is not his task. So that's why we have to stop the race condition. Okay, how can we do? We can use synchronizations. If we use synchronization, what will happen then? Then what will happen is that first, so this one will be converted in this way. The first user will come, he will print his one. So the first image will complete. When user will left the printer, then another one will come, user 2 will come. Then his task will be document will print, then he will complete. Then another user will come, another user can insert the printing sessions. Then he will print, so then his photo will print. So 3 different tasks. So when he will come, so that times other will be locked. They will not come to, the door will be locked. So I have in the room, so I will lock the room from the inside. So lock. So nobody can insert now. Everyone will go around. Okay. Everyone will provide moving here and there. Okay. Then when I unlock and then get out from the room, then another person can come and lock the room. And then he will do his process. And then again, he will unlock and go outside. Then another person will come and take the room and use this room. In that way, basically, we have synchronization. That is called synchronization. But who will come and take the room? We don't know this one because threads scheduling will depend on the JVM. We don't know who will come first. Okay, so so to do that, we have to use synchronization. Now, synchronization, the capability to control the access of multiple threads to any shared resources. Printer is shared resources here. Okay, Java synchronization is a better options where we want to allow only one thread to access the shared resource at a time. Synchronization is built around an internal entity known as lock. So by using internal entity, which is called lock. By using lock, you can use synchronization. When you enter the room, that time lock the room. So that's basically the lock. This lock objects you can use to lock the access, lock the room. Okay, something like that. Lock the room. Okay. Every object has a lock associated to it. Objects are associated to lock. So by convention, a thread that needs consistent access to an object's fields. There are object has instance and object has method. So anyone a thread can access. So if a thread needs object fields, he must lock before accessing them. Before accessing them, the method he can access. Before accessing them, he must lock this one so that other cannot access the object's fields, object methods. Then release the lock when it is done. So he will go out, then another one can access the object fields. Okay, so that's we're gonna do from now on. So first I'm gonna show you one of the code that's basically not synchronized, which is basically we have in Java 3. So we're gonna execute Java 3 while open. We have Java 3, we have 3, okay, Java 3. So inside the 3, if you see here that when you execute this code, so we have the task, we have a task class. So this is our task class. So this is our task class. We have the task class, task class, and this is my driver class. So this is my driver class. See here in the task class, we have print thread implement. So this is my runnable. So we are using now runnable interface. Okay, runnable interface, and which has a run method, and this one is my constructor. Inside the constructor, I have two strings, and I am assigning to the local variable to the strings. I mean instance variable to the string, and then I created the thread objects, and then thread.start. So I execute the threads from the constructor. And when the thread will starts, that times he will execute the run method. So first he will print str1. So st1 he will print. So and then he will sleep for 500 milliseconds, and then he will print st2. Try catch must meet with sleep method. So sleep method is blocking the thread to execute mode. You will stop the execution for a certain period of time. Sleep. So thread will be limited amount of time. Thread will not execute anything. So this one is 500 milliseconds we have given. So 500 milliseconds, thread will not execute anything. Okay. And then we'll print S2. Okay, fine. So now we have created the task. So new print name thread task objects. Hello there. So the first thread will come here. Hello there. So he will call this. So these objects he will run, and then thread.start. So he will execute this one. So first it will run hello. Then he's going to sleep 500 milliseconds. In the meantime, other thread will come and he will start. So he will also start. So he will execute how are, and then he will also sleep. Then the third one will come and he will execute like thank you, and then he is also going to sleep. And then after 510 milliseconds, anyone will be pop up. So let's see the last one will pop up first. So last one will pop up very much. So he will come and he will, so he was in here. So after sleeping method will complete, then he is executing the second part. So very much. So this thread will execute and finish. Then the second one will execute, how are you? So then you will be and finish. Then the third one. So you will see the haphazard situation. These are not constantly like what you want. Hello there should be there. How are you? Thank you very much. It should be written. The thread should complete his task. So before completing his task, anyone should not interfere. In the middle of his task, anyone should not come and do his task. So thread should be independently done his task, complete his task first. Then other one's tasks will be started. So that's why this one is unsynchronized. Okay, so let's see how it's worked. Let's see. You see, hello, how are you? So before his task, hello to there. So the other threads will come and print their words. So between the how are, then thank you. So other one is coming and printing because he's in the sleeping mode. In the meantime, other one will come and print. Now we want to make this one synchronized. Synchronized mean what? Synchronized mean that if anyone who will come, we don't know. Who will come, we don't know, because who will start first, we don't know. Okay, this one is depending on the scheduler. So let's see that first one will execute first, or let's see third one will execute first. So third one will enter his, so this one to this one is basically our critical sections. This one is the critical sections, because this part, if anyone will enter after completing this one, then another thread can insert. Otherwise, the other thread should not insert. So thank you, he will print, wait 500 minutes, the 500 milliseconds, and then he will print very much. And then he will go out, then another one will come. So he will print how are, then he will print you, and then go out. Then hello, then 500 milliseconds, and then you. So it can be like, hello there, how are you? Thank you very much. Or it can be, how are you? Hello there, thank you very much. Or how are you? Thank you very much. Hello there. Or thank you very much. Hello there. How are you? So everyone task should have to finish. Who will come print doesn't matter. But his task should have to finish, and then another one will start his task. So that is basically sequentially. When he will start the task, one thread will start his task should have to finish first. Then another one will start his task. So that's basically we want. Why? So this place. So this place is the most critical part, where a thread need to start and thread need to finish. So that task, so before entering this part, we can make log, so that other cannot execute this part, other will go around. And when you, after, when you will finish this task, you will make unlog. So when thread will enter, you will make log. So nobody can enter these sections, only the thread who has the log, he will insert the sections and he can execute those, and then he can only make unlog and then going out. So when he will go out, then another person will come, the log is free, so he can take the log and then inside the room, and then he will go out, okay? And then he will unrelease the log. So the door is open, anyone can come. In that way, basically the log can help to make synchronizations. Let's see how this log can execute. Let's go for this one. So now we have here, you see, we have, so we told that the log is affiliated with, the log will be affiliated to an objects, right? So we have created an objects. So here we have created an objects with the display, we have with the display string. So this one is the method that is inside the like string 1 and string 2 and 500 milliseconds. So that's we put in an objects inside the inside a class. We have a methods. So inside this method we place this one, and we have the run methods, and we call this objects method from the run. Okay, so because we have taken only one objects, and those code we place inside the object method display. Nothing else. We didn't do anything new. Just we created one objects. So now task object also can call another objects. That's we are telling that thread can call another objects or another methods they can call. Now for this one, you see, those are the same things that we do previously. Okay. Now here is the main part. Task class we have, as we are using t.display string. So task.tastelog.display string, we need to call this one to be executed by a thread. So tastelog.display string. So we have to create the object of the tastelog, because those are not static methods. We have to create the objects. We are creating objects here. You see, tastelog t equal new tastelog. We created an objects. And these objects, so t dot display string, we call the display string, and we pass str1, str2. So this one will come as in here, string1 and string2, and then execute. Okay, so if you can stop in here, if you remove those part, you will see the same things that we see the previous program unsynchronized. You see that we have the same output of the previous program that we had, the previous program output, like they are in the middle of another threads, the other threads also writing. So that's we had, right? Okay, now what we're gonna do? Now we are using synchronizations inside the objects. So what we are doing, we are using the log like this one, private static log. So this one is an objects we have. So it contains one interface type is log. So log interface type, a variable we have taken, so which is creating an objects of reentrant log, an objects we have created log. Fine. So and this one is static so that everyone can share. Okay, so static, so lock. Now lock dot lock, before entering this method we call lock dot lock. So if one thread will come, he can lock this one, he can take this lock and lock dot lock, so this method will be locked, other threads cannot come. When the thread will go out, we can call lock dot unlock, lock dot unlock. So if this one is my room, before I told you, so T1, T2, T3. Let's say I have 3 threads. T1 entered this position, this portion. So he opened the door. He find out the door is open. So he went and locked the door. Lock. And when he go out, then unlock. So the door has been closed. So he went out. So then T2 will come. So he find door is open. So he will come and he will stay there. So when T2 is stay there, T3 will come. He find out the lock has been given. So he cannot enter the room. When T2 will pass, then T3 will come and enter the room. In that way, basically, we can make synchronizations. Okay. So what we did is that we create an objects, we create a reference variable of lock type, which is basically an interface, and lock type, and this one is implementing this interface. That's why it is the parents. So we are creating the lock, new reentrant lock. Okay, so this one is the objects we have created, and that class is implementing the lock. Okay, so lock dot lock. When you click lock dot, so lock is the name, dot lock. This is the method name. So this method will lock the door, and one method, one thread will inside. Then he will print S1, then 500 he will sleep, and then he will take S2. Then till the unlock, the other thread will come and they cannot enter this one. They will come and they cannot enter. Okay, so they will not. They want to insert, but because he's napping, so he don't care about others. When his napping has been finished, so he will do his task, and then he unlock the door. When he will unlock the door, anyone, depending on the scheduler, any one of the thread, other 2 threads will enter and make the lock. So other one cannot come and cannot insert the row. So he will also rounding. So that's mean that one thread will finish his task. In the mean of one thread execution, other thread cannot execute. That's we are doing. So printer task also we can do like that. Okay. So for printer task, before printing, we have lock, and when it has been finished the printing, then unlock. Then another job will come and he will lock and unlock. In that way, basically printer also, network printer also work. Okay. So that way basically we can execute, and you see we have just created the objects like with the strings that we want to place, and then we have the thread we have created and thread 1.start. That's it. Okay, nothing else. So just we are running this one, and you will see that now it is synchronized. Now it is synchronized. Hello there. So hello there. Although there is a time has been taken. Now the second one, maybe how are you? So how are you? And then third one, thank you very much. So the full one has been printed. Before it was not, but now it has been synchronized. This is one of the way to make synchronization by using lock. Okay, that's we have seen. So lock has been affiliated with objects. That's why the objects, you see objects fields display object fields. If lock has been used, so it has been used in the object fields so that the other cannot access the same object fields. Like other will run and they cannot access the same object fields. Before one will finish, then the other one will execute. So that's basically the locking mechanism we can use to make the threads synchronized. Okay, this is one of the way to make synchronized. There are other ways also. We have like synchronized method, synchronized block, synchronized method, or static synchronizations. That's 3 are called mutual exclusives. Mutual exclusives. Those are as like mutex, mutual exclusives. One variable is there. So threads will take this one, and thread will unlock this one. Thread will lock, and thread will unlock the mutex. Others outside threads cannot access this one. Thread only who will take unlock, he will make lock. So no other will come. So he has the key, he has the lock. So he is the only one who can unlock. That's basically called mutual exclusive. Okay, mutual exclusion. Fine. Now we are coming to other methods. So let's go for, we have seen 3. So let's go for 3.1. So file open. So 3.1. Why it is not in here? Okay, so why it is not working like to be able in here? Okay, 3.1 file open. Now it is okay. So 3.2, then we'll have 3.3. 3.3, and then we have 3.4. File open. We'll have 3.4. Now see here from 3.1, what we did here. Yeah, this one is the lock and unlock we have used. Now let's go to 3.2. 3.2, what we did is that synchronized method. 3.2 we have synchronized method. What see here, see the class, like we are not the same one as like 3.1. We have the test log T, and we are not creating in here. We have placed test log from here, so that has been shared by everyone. So T log T class is shared by everyone because everyone need to use this. Every thread need to execute this. That's why the T has been created in here, and then passing this one. Okay, so it's important because when you don't want to create objects has been locked, but now object need to pass because the thread need to know which objects they are dealing with, that need to pass. So we have to pass the objects as well. So when you are passing these objects, so it has been T equal to T1, T equal to T1. So now we have these objects already shared objects. So this one has been shared by three threads, has been shared this one because everyone is pressing this one. If you take this one as a new text one, that is local, that's not shared. That's the problem we have. So that's why we have to use shared one so that everyone can share this one. Okay, and there you have to need synchronization. Shared one, you can make synchronization. If it is local, there is no synchronization in there. You do not need the synchronization, but it's not usually work with synchronization because everyone should have to share the code. So that's why the object has been created in here in the driver class, and then we pass this one. So now we have T1, so T equal to T1, and then T dot display string. You see, now we are using synchronized Q1 in the method before. Now lock, we are not using lock, just synchronized. The keyword we are using on top of the method, synchronized. That's it. So every class will come, every thread will come. When they will call, automatically they will be synchronized. So you do not need to use the lock. They will automatically lock or unlock. They will automatically do that things. Okay. So you just write synchronized in on the before the name of the method. So that's gonna run. You see this one is also synchronized. But remember that the objects where the method is synchronized, so that should be shared. Everyone should have to share. Everyone should have to share. Everyone should have to. Object should be shared. Object should not be local. Locally, you do not need to create in here. You have to create in here. Okay. Now another way we can do, which is basically called a block synchronized. This one is synchronized method. Now synchronized block. Synchronized block we can create like this one. It's a simple one. We can create this one without creating an object. We can take this one in here and take this one in here to see display string. So we can take this one as a method. What is run? And this method I have taken inside my class, tax class. Now I'm not taking the another class. Okay, I'm not taking another class. Okay, just taking this one into the method as a local method. So member method. So we have taken a member method. Now, when you use member methods, so it should be shared by everyone. Everyone should have to use that. So it should be static. So that times synchronized static you have to use. Synchronous static, because this method should be shared by everyone. Every thread can access this one. So when you are calling this one, so that times synchronous static we can use, and we have seen that it's also working the similar way. What is this? It should be 3, 3. Now it should be okay, I think so. So either you can use synchronous static, or you must need to object should be shared. Okay, so lock also is lock should also is static. Okay, remember this one. Like the synchronous static, the method should be shared, so that's why static. The text, the class should be shared, so that's why we have placed the object in here. And or the lock should be shared. So file open, we have the 2, 1, 3, 1. So here the lock also need to be static. Okay, remember these things. Okay, where you need static and where you not. Now we have the last one. We have block. We have block. We have block. See, this one is the block. We have test, and test is common to everyone. And then rather than synchronized in on top of the method, we can create as a block. So these are the showing example. Okay, you can place in different places. Why do you need synchronization between the code of the threads code? You need the synchronization. You can place the either you can call synchronized method when you have methods, or inside the method if some statements you need to block. So you can create synchronized block like this. Synchronize this means these objects, and then system.out.println s1, and then so this one is in the block of the synchronized, so that will automatically synchronized. Okay, so the thread will synchronize in here. So either you can create synchronized block, you can create synchronized method, you can create synchronized static method. In that way, basically you can use and create the methods to be synchronized. Okay, so that's all from synchronizations we have. Now another one, this one is called mutual exclusions, that the synchronization will be done by the thread itself. Thread itself. Thread can enter here like synchronized static. He will come here and then he will lock himself and he will unlock himself. Without unlocking himself, he will not access to, the other cannot go to the section, go to the code, specific code, synchronized code. So only one can access. Then when he will go out, then the others will come. So the synchronization is totally, the lock and unlock is totally depend on the thread which is inside the room, which is going to inside the room. He has the power and he will unlock himself, and when he is locked himself. So he has the power. So when he will unlock himself, then other thread will come. So he is doing lock and unlock by himself. Now another methods we are going to see here is another method. This is the last program we have. Another method which is called, which is basically called corporate class. So like two class we can run sequentially, parallelly or concurrently. So the conditions like let's see uh, let's see that sequentially they will send a message, send message. You will receive, and after that you will send message, then he will receive. So after sending message, he will be in wait for receive any other message. So you will send, so he will receive, and he will send the message. When he will send the message, before he is waiting, now he is sleeping. Okay, waiting means forever waiting. Other need to wake him up, awake him up. So he will notify him. So when he will notify, so before sending the message, he will notify. He want to receive, then he will send message. So then he will receive, and then he will wait. after receive, before going to send, he will notify him. So who is going to execute, that will be depend on others notify or not. So others is waking you up, but in the Mutex one, you are the one who is locking yourself. Like in here, you are going to lock and you are making unlock. Till then others cannot come. So lock will be on your hand, but here unlock is not your hand. Other person will unlock you. He is also other person will unlock you. Okay, so that way basically synchronization will maintain. So that synchronization is called cooperative classes. Two classes cooperatively, one will send notification to others to wake up, and till then he will wait. So his hand doesn't have when he will wake up. The wake up call should have to come from others. Okay, so that's basically called wake up call. Okay, that's been notified. So otherwise he will wait. So the class can wait, I mean sleep can itself, but awake can happen by the others one will notify. Others one will provide the signal, then I will wake up. So that's basically called, that's the difference between mutual exclusions and cooperative class, interprocess communication. Okay, so interprocess communication or inter-thread communication way. Okay, so that's can happen. So that's we're gonna see here that how this happened. Okay, so so let's go to check. So this one is corporations, inter-thread communication in Java. Okay, so now we have inter-thread communications we're gonna do by using a common problem which is called producer consumer. Okay, so producer we have a box. Inside the box we can place some items. Let's see what items we can place. So producer we have one class and consumer we have one class. The producer produced the item. So producer produced the items. Okay, he produced the items, he will put in the box. Okay, box in the middle. Okay, so one items, only one items. We are talking about only one items, one producer, one consumer. Okay, now and consumer task is to take the item, because producer will produce, like farmer will produce, and consumer will consume. So he will sell that one to others person. So he will take away. So he will produce, put in the box, and he will take away the value from the box. But if the speed, if you don't have any assumption about their speed, so it may happen like that. Producer will produce, and it is much faster, so he can produce again. So if he produced again to here in the box, he can place. So other items will be removed. The previous item will be removed. We don't want that. Okay, previous item should not be removed. So producer will produce, and then if you find out that already box is already produced or produced has been done, so he will wait. He cannot place the item in here. He will wait. Consumer. So on the other side, it may happen that producer produced, consumer is much faster than producer. So producer produced and go for another one to produce, In the meantime, consumer came, consumer take away this one, and again he want to take, but it is now empty because the producer is not producing here. So consumer must need to wait. So how can we make synchronized in here? Okay, so what we can do is that when producer produce the item, you will notify. So what will happen if he is in the waiting state? He will wake up. He will take the item. Okay, when he will take the items, so he will take the items, he will notify. So like producer is producing, so he may be wait in here. So when he will notify, that times the producer can produce the items again, because this one is empty. So whenever he will take the items, he will notify producer. So if producer is in wait state, so he will wake up and produce the item. He will place again. So in the meantime, till he's producing, it was empty. So the consumer will in wait state. So when the producer will notify him, then he will await and take the item from here. And he will take the items from here, and producer will produce and wait situation. He go to the wait situation. Consumer will take the items, notify. No, you have to produce because I have taken already. When consumer will take items, after notify, he will go to sleep. He will wait because he has taken the items. Now he don't have any work. So he will go to sleep. Now, after wake up the producer, he is going to sleep. Then producer will produce again, wake up and produce again. Then notify the consumer. Consumer will have it and take the item. This program we need to do. Okay, we're going to do. So let's go for this one. Okay, so we have the program is producer consumer. These problems you have learned from Java. I think you have learned in Java. So we have like Java threads. We have the producer consumer program in here. Okay. Now you see that producer consumer first unsynchronized one. Let's open the unsynchronized one. What will happen? Producer consumer unsynchronized. Do I have unsynchronized? No. Okay. So I have the synchronized one directly. Okay. So synchronized one. Okay. So what is the producer part? Let's go for the producer part. Okay. Producer part. Producer will produce the box. So produce the box, I will see like box type items. So he will has a box and a number. Okay. So producer, when the producer object will be created, so he will create the box and provide the number associated with the box when the producer will initialize. During the run, he will execute box objects he has created. So box dot put this number. So the number he will place and comma I. So number he is placing this one, which number he is placing. And then try. So after placing this one, put, that means he is placing the box. So box we have, box object we have created, and box has some method. Okay. There are two methods inside the box. One is called get. So consumer will call get and producer will call put. So box dot put, and it is shared by both. So producer will produce 10 items and put it into the box. Let's see number one. And call, and he is going to sleep. He is going to sleep. You see, he is going to sleep for some years. He's going to sleep. And then again try to put this one. Okay, so that's for so producer, what he produced will do. Producer will produce this one, and then few minutes he will go to sleep, and then again he is gonna produce. He's gonna produce. That's producer job, is to put some items in the box and then go to sleep, again come back, put some items in the box, go to sleep, put some item in the box. That's the producer job. Fine. Producer is doing that one. What is consumer job? Opposite one. Like consumer will just get the value. So value is 0. So he will get the value always. Always he is try to get the value. Okay. But we need synchronizations. That producer will put, then consumer will get the value. So how can we do this one? We have the box. Box will maintain synchronization, obviously, because this is the critical sections. We need to maintain the box. So let's see how. When the get method he will call, take the items. So if we have a what is this called? We have a variable. Let's see variable, Boolean variable available. If data is available, then this one will be true. If data will be available, so that means producer produce the items, that means it will be available, will be true. So when I will get, then I will check that available is true. If available is false, that means that I cannot take items. There is no item. So I will be in sleep. I will wait. Okay, I will wait. If available is true, then I have to, available is true. That means I can take the value. So I will make available false. First I will make available false so that next time I cannot come. And I will take the item, I will print the items and notify all. notify all or notify all. Okay, so it's very important. You can write notify or notify all. Notify, but you have to mention the objects as well. So mention the threads. We don't want to mention the threads. That's why we want to notify all. So everyone will notify. Whoever waiting, so they will notify. So if available is true, then I will make the available false because I'm taking this item. Available false, take the items, bring these items, notify all. Okay. The next time when I'm gonna get again, so I will get that available is false. So I'll be in waiting state. Okay, I will wait. Now, how the producer will do? The producer will produce, so he will call put. So when he will call put, the same way he will check available is what, true or not. If available true, that's when item is in there. I cannot place items. So I will be in wait. So I will be wait. If available is false, that's mean I have to place the items. So I will place the item. I will place the items. So make first available is true, then place the item. Available is true. First place the item, and then available is true, and then we'll first place the item. Okay, not available is true. Not first. You will make available first item will be contents equal to value. Then available is true. Okay, and then we'll call the what the items he is printing. Then notify all. Then he will notify. So whoever sleeping, so now can get available is true. So he can get the item. Okay, and now if I will come again, so I will feel that available is true. So I will go to wait. In that way, two methods in the box, puts and gates, is making the synchronization here. So and the so first the producer, if the producer will run first, that should be producer should be run first. Or okay, no problem. So if get will call, so if there is no item, he will be in the waiting state. So no problem. We don't have any problem. So whoever run first, we don't have any problem. Okay. So now if we run this one, you will see that. So first producer will produce, then consumer will take that items. Otherwise not. That's we're gonna see. You see that producer put first one, then consumer get, then producer put one, put again, then consumer got one, producer put two, then consumer got two. So in that way, sequentially, one will place put, and then other will take away, and then you will do. In the meantime, I will produce. So I will produce and put it there if available. So there is a sentinel value we have, which is called available, which is basically which is providing the information to the producer and consumer that what the task they need to do. Either they will go to sleep or they will take the value for consumer. For producer, either he will go to wait or put the value in there. So what he will do? So that will be depend on just this variable, which is available. Same thing we can also use for chatting as well. One will place message, then the other will place message. So that's also for inter-process communications we have. So that's I taught those things into operating systems, okay, inter-process communication and everything, because those are the part of operating systems. So I usually use like C programming language and Linux-based systems to tell my students that about IPC and about mutual exclusions. Anyway, so we have Java, we can also learn, we have threads, so we can also synchronize in that way. So that's the program we have. So you can just go through that way. So first, you have to understand what is producer and what is consumer. And you have to understand the box very well, because the box has two methods. One is put and one is get. So these two methods are making synchronization basically in the box. So these two methods are responsible. And we have one variable in here, which is called available. So depending on that, the producer and consumer will work. So consumer will take value if available is false, then consumer will not take value. So consumer will be in waiting state. If available true, consumer will take value. So remember this one, consumer will take value. So consumer will take value, and then he will make the available false first. He will make the available false first. Available is true, so he will make false first. Then he will take the items. He will notify. He will take the items and then notify all. Okay. But on the other side, we have for producer, we have he will place the item first, and then he will place the items, then make available equal to true, then notify. Okay, so without available change, if you notify, this is a problem. So please remember, so before notify, available will be false and available will be true. Okay, before taking the value, you have to available false, otherwise you cannot get it, you cannot access there. So you have to make available false and then take the value, so the other cannot access in here. Okay, so that way basically we can work. And we can assume producer can produce. So anytime anyone can come. So you have to maintain a multiple objects. So array will be there. So how can you do that? So please think about this. Okay. So this is your task. Okay. Any question?